made a mini mixer. Yeah, and you can see the layout here. We have some equalizers with 4 buttons, 4 moving buttons and 4 round buttons, and then we also have a visualizer.
One of the buttons actually displays the current volume of the audio controller. The audio controller can be configured by IC2 communication, and the way we talk to it is I2S communication.
Let's see.
Most of the audio is done in software. We have a very little core we got from Project Online, and most of the audio modification is also done in software.
Yes, and our graphics is done through a VGA cable connected to a screen, and the layout is done with the pictures in PPM format, which is stored on an SD card and put into the Cyber, and then we load it through software and put them on screen.
So the software that you're talking about, is it something you wrote or is it something you got?
We wrote the software.
Okay.
Yes.
We use the library for accessing the file systems, but everything about that we made ourselves.
Mm-hmm.
And we also this visualizer function. It uses a Bassenheim algorithm to show to make the lines. It's an algorithm used for making lines in all dimensions. You can see, and
Recording, so.
we can see we can make a line in each direction without problems.
Yeah, I mean, 45 degrees, it's also easy to draw.
True.
And other degrees are more difficult.
Yeah.
But I guess you can use any angle, right?
Yeah,
So
any angle. Yeah.
Was it something you wrote? You got only the algorithm, or was it the library that you used?
It's an I wrote. It's an algorithm which is made beforehand, so I just use that.
You just implemented it.
Implemented that. Yeah.
Okay, so but you implemented it yourself. You just
Yeah.
got the algorithm and you
Yeah.
implemented it yourself.
Exactly.
Okay.
We also have a couple of functions for the sound, one of them being echo,
Yeah.
and you can actually change the delay you want on the echo. It has a certain delay set at start, but you can amp the delay and listen to how the echo increases.
So it
Yeah.
kind of imitates a scratcher.
So to decrease the suspense, can you show a demo so that we can also see it while we talk about it?
Yeah, of course,
Yeah.
of course. Play the track.
So now let's.
So we can see the button
Goes up and
the
down.
volume up and down
And to control the volume up and down, how do you do that?
on the keyboard.
On the keyboard?
You can use the plus and minus keys on the keyboard.
The project is completely controlled with the UART.
Yeah.
So
Yeah.
you have to connect it and write to it.
So it's a serial terminal you have in there.
Exactly.
All the work is done on the FPGA, which is here,
Yes.
there,
You configure us the input of the
and then the
UART.
PC it's only used as a serial terminal, nothing
Yeah,
else.
yeah.
Yes.
Just so we can see what's happening.
Yeah.
We would have done it on purely on GUI,
Mm-hmm.
but we didn't manage to get it done.
We had some problem with the mouse and
Yeah.
it's rough. But we also have a function to record and playback
The sample you recorded.
Yeah.
So right now the sound comes from the
Computer,
computer, right?
Yeah. So now I'm recording, and now it's finishing, and we can see the visualizer is
Changes.
changed because of the recording. And now let's hear it. Let's reset and record it again.
You can see it changed, but we didn't manage to do it in real time. That would be the next level.
Yeah. And we can scream and
Scratch.
Play the samples when we want in live feedback.
and
What about the echo thing? Can I hear the echo?
yeah. Let's
Try to add more delay.
Taking it a little bit.
The sound is also a bit distorted, isn't it?
Yeah, it does distort it because it changes some of the sampling rate. because we hard coded the way we do sampling.
Yeah. We sample at
8 kilohertz.
8 kilohertz, and we've done it.
Okay, so it's not the best sampling rate for music.
No,
It's not
really.
studio quality, no.
Yeah.
Yeah.
And
That's also a thing we would increase if we had to.
To check the echo, can we have somebody talking, for example, and then hear the echo of that talking person?
I mean, yeah, we can
Some
play
video
some,
talking.
Video talking.
Some TED talk or something. It doesn't matter.
Just taking an interview. Any kind of interview.
If I heard voice power and dignity, I watched the buy her own houses for the time, and then talk to Boston. And I should have learned to conduct yourself and protect yourself. And Los Angeles
Bit distorted.
It's not the best quality.
yeah.
I can't really hear much echo. I hear this distortion, but not much of an echo.
It doesn't become a precise echo. That's also because of the sampling
Yeah.
rate.
Yeah.
Okay, let's look at the other. I saw only one of these sliders move.
Yes.
Yeah.
What about the other ones?
We haven't any
Functionality on them.
No,
Not yet.
we just it would be the same.
It would be the same functionality to move them, then we just had to add another effect,
Yeah.
basically.
Okay.
We
So
just
it-
haven't got enough functions which.
Our idea was to put filters on them, and you can change how the filter would pass. Like you can increase the low pass range or the high pass range on the scrollers, but we didn't complete that.
So in this project, what was the most challenging thing that you
I think
were
it
dealing
was
with?
to combine the plug designs with the audio and the graphics. We used a lot of time on that, and that made the process slow down, and that's why I think we didn't get the other functionalities to the buttons, unfortunately.
And we
Okay.
also had a very high expectation of what we were able to do. So when it started falling down with not being able to get the ADC converter to work, and when the DMA interrupts, it just it broke. So we had to narrow it down.
Yeah.
So you had a rather complex design for the audio part, right? Filtering and all that stuff.
Yeah.
And it was kind of too much for the period we had.
Yeah,
Too
I think
complex.
the problem was that we didn't work together. We were separately, so when we had to put it together, there were so many variables that you have to do precisely, and
Yeah.
it just too hard to implement.
So it would be better to merge it in an earlier time next time,
Mm.
to have a minimum product
Yep.
to begin with, and then you can expand on it.
Yep.
For future notice.
But it's also, we learn from our mistakes, right?
yeah,
So
definitely.
that's why we're students.
So now others can use that as an advice.
So, okay. So, is there any other feature you would like to show, or was it?
We have a little fancy background with some spiders, just
Yeah, we can,
a little
change
feature.
The background if you want. And, yeah.
We can pretty much load any picture inside, and we can move it in
Okay.
whichever.
So, what's the thing you are most proud of in this project?
It must be the visualizer made from Marcus, I guess. So it's really nice, I think.
Also, the way we get pictures, I think we put them into an array, and then we just have a function which takes that array and the size of the picture, and then it just prints it out on screen with no problems.
Mhm.
So it's really easy to get.
So you could, for example, show lots of text relatively easy, right? I see that you wrote Pioneer there.
Yeah.
but that's basically just a picture. But we could do it.
okay. It does a static picture. It does
Yeah,
not-
it is.
Yeah.
But we could
Yeah.
do it with letters easily without
Yeah.
our functionality in our program.
Yeah, just have an array of pictures with each letter, and then and then how to call it, map it to the strings we want to write. I think.
Okay.